Hello everyone, am I audible?
Yes, sir, you're audible.
Okay. Have you finished parabola, the exercise of parabola? I guess not. Shabya, Ashma, Abdul, we finished parabola, right? In the last class. Yeah, have you finished the exercise?
Yes, sir.
Any doubts?
No, sir.
No. Okay. Ashma, what about you?
Sir, I also did the exercise.
No doubts?
No, sir.
All right. And Abdul? Is your mic working today? No. All right. Okay, let's wait for a few minutes for the students to come. All right. Okay. Today we are going to start ellipse. All right. Shabya, can you tell what is the thing called parabola? Definition of parabola?
Yes, sir. So parabola means if you take few points, these points are equidistant from the fixed points, and then the fixed lines.
Right. The distance between a fixed point and the fixed line is constant, right? All the points.
Yes,
And
sir.
it becomes a parabola, right? In ellipse, we take the sum of distance from two fixed points. And this is always constant. Don't write this down. All right. I'll be giving you the definition. Just to understand, the sum of distance from two fixed points. That means there are two fixed points. They cannot move. All right. Let's call this A and B. And the collection of all the points in that plane where the sum of these distances, let me call this P, PA plus PB. If this is equals to 10, then if there is another point P dash, then P dash A and P dash B this should also be equal to 10. Is this clear? Ashma, Shabya, Abdul?
So no matter where are the points, the sum is going to be same.
Yes, the sum has to be same. All right, all the
Okay,
points in that ellipse, if you calculate the distance of each point from A and B, and you add the distances, that distance, the sum of distances should be equal for all the points in that ellipse. All right, let me
Okay,
explain it. Yeah, suppose this is one of the ellipse. This is the two fixed points. All right, F dash and F. If you take any point here or here or here or here, any point, and you calculate the distance, this and this, you add them and you calculate this and this, add them, they will be equal. All right, that distance will be constant. This is
Okay.
the condition for ellipse. All right.
Yes, sir.
Okay, Ashma, what about you? You're not audible. All right, write down the definition. All right, Ashma. The definition is an ellipse is the set of all the points whose sum of distance from two fixed points is always a constant. All right, the two fixed points are called the foci. If there is a single point, we call it focus. If there are multiple points, then plural is foci of the ellipse. All right, write this down.
Done, sir.
All right. So in this diagram, this is the focus, right? Foci. All right.
Yes, sir.
Let's discuss the definitions first. After that, I'll explain what those are. Major axis. There is a term called major axis. All right. The line segment through the foci of the ellipse is called major axis. Minor axis. The line segment through the center and perpendicular to the major axis is called the minor axis. And vertices. The endpoints of the major axis are called the vertices of the ellipse. Write this down, then I'll explain. All right. All right, done.
Yes, sir.
Yes, sir, done.
All right. Okay. Suppose this is our ellipse. All right, and these are the focus, the foci f1, f2. Ashma, can you tell me what is the definition of major axis? You are not audible, Ashma. I cannot hear you. All right, Shabya, can you say the definition of major axis?
Yes, sir. The line segment through which the foci of the ellipse is called major axis.
Major axis. That means a line segment that is passing through the two foci, right? Something like this. So this line segment, which will pass through the foci of the ellipse, is called major axis. All right. Yes, Asma, right. After that, the definition of minor axis, Shabya.
Yes, sir. The line segment that passes through the center and is perpendicular to the major axis.
Right. Did I tell you the definition of center or not?
So what?
Did I tell you the definition of center? Center of the ellipse?
No, sir.
No. All right. Write down the
So after
midpoint.
minor axis, you gave the definition for what is.
All right. I didn't tell about center, right? Write down center. Midpoint of the line segment joining foci. All right. Okay, so center is the midpoint of the line segment between f1 and f2. This is the center. And the minor axis was the line segment through the center and perpendicular to the major axis. A line segment that passes through this center and perpendicular to this major axis. So a line something like this, right? Abdul. Shabya, is it clear?
Yes, sir.
All right. Ashma and Abdul.
So, sir, here y-axis means minor axis, and then x-axis means major.
Major axis. Absolutely right. But see, we are not drawing this ellipse in coordinate plane now. I'm just drawing a ellipse, right?
Okay, so I thought since it passes through the origin, I consider it like that.
Yeah, absolutely. In your syllabus, the only ellipse is passing through the origin, but in general case, ellipse can be in any way, right? An ellipse can be like this also,
Yes, sir.
right? So this will be
Yes,
the
sir.
major axis that passes through the foci. This will be minor axis, right?
Yes, sir.
Yeah. After that, vertices. The endpoints of the major axis are called vertices. That means this is a vertex. This is also a vertex. All right, very easy.
Yes, sir.
Okay, let's draw this diagram if you want. After that, we'll draw a
Done,
good
sir.
diagram. Yeah. Just give me a minute to draw it very. All right, Shavya, which is the major axis here?
Sir, AB,
Yes, AB, and minor axis is
CD.
CD. Absolutely right. All right. So in generally, we name this C comma 0 and minus C comma 0. All right.
Yes, sir.
And this will be true for ellipse and hyperbola. All right. C comma 0 and minus C comma 0. We name the vertex as A comma 0 and minus A comma 0. All right. And this will be 0 comma B, 0 comma minus B. All right.
Yes, sir.
So now that we know all the coordinates, all right, this is the x-axis, this is the y-axis. Right. Shabir, can you tell me what will be the length of major axis here? Just by looking at the diagram.
So if I consider A to origin as 2A, then origin to B as 2A again. So I guess it is 4A.
All right, see, if this is the origin,
Yes, sir.
that means this from O to B is only A, right?
Yes, sir.
And same is from O to A. That means the total length will be 2A. right?
Okay, sir.
Yeah. Ashma, is it clear? Ashma, your mic is not working. Please respond in chat. All right. And the length of minor axis will be
Sir, in parabola, why did we take length as 2a?
length of what?
Length, like half the length as 2a.
Yeah, that was length of latest rectum, right?
Yes, sir.
Yeah, here this is a new property of ellipse that is called major axis. All
Okay,
right.
sir.
Yeah, this is not the latest rectum. All right.
Yes, sir.
And the length of minor axis will be 2b.
Yes, sir.
Absolutely clear.
Yes, sir.
And the distance between the foci will be, Shabya, what will be the answer? Distance between the foci.
So by using distance formula?
You don't have to use the distance formula. You can use the distance formula, but you can just calculate, right, easily. From O to F1, the distance is C,
Yes, sir.
and from O to F2, the distance is also C,
C, so 2c.
2C, right? So write it down. The length of minor axis is 2B. Distance between foci is 2C. All right. Draw this diagram and write it down. All the data. All right. This naming should be absolutely clear. This is minus a comma 0. This is a comma 0, 0 comma b, 0 comma minus b. Focus is minus c comma 0 and c comma 0. Origin is center. All right.
Yes.
Yeah. Draw this diagram and write it down.
Done, sir.
Done. All right. Write down relationship between semi-minor axis, semi-major axis, semi-minor axis, and distance of the focus from origin, from center. All right, that means A, B, and C. All right. See, if the length of major axis was 2A, that means semi-major will be A. Length of minor axis was 2B, that means semi-minor will be B, and from center to the focus, the distance is C, right? We have to see how they are related. All right, write it down. Right, draw the diagram again. Done? Shabia, Ashma, Abdul?
1 minute, sir.
All right.
Done, sir.
All right. So according to the definition of ellipse, I can take any point on this ellipse and find the distance from the focus, right? So if I take a point B, so distance from foci will be F2B plus F1B, right?
Yes, sir.
So can you tell me what will be the answer here, Shobya? What will be this distance F2B plus F1B in the terms of A, B and C? If this is A comma 0, this is C comma 0, this is minus C comma 0. C, F2B, that means you have to cross from this to the origin, and this is C, and from here to the point B is A. So F2B is C plus A plus F1B. F1B is
C.
this distance. Sorry,
I thought it was C.
no, this is not C. From origin to the focus is C. We have to take this distance, right? F1B.
So it is A minus C.
A minus C, absolutely right. So this is A minus C. So this is the total distance, sum of the distances from the foci of the point B. And this is 2A. Right?
Yes, sir.
Again, I am taking another point G, which is here. All right, I have to calculate F2G plus F1G. And this should be equal to 2A because in by the definition of ellipse, all the points have the same constant, right? How to find F2G? I can join this. This is a right angle triangle. This is C, this is B. That means this distance is B square plus C square under root. Right?
Yes, sir.
So F2G is under root B square plus C square. And same with F1G, because this is C and this is B. So this is also B square plus C square under root. So again, I'll be writing this equals to 2A. Is this step
Yes, sir.
clear? All right. So this is 2 times B square plus C square equals to 2A. 2 and 2 is cancelled. Squaring both sides, I can write A square equals to B square plus C square. And this is the relation between A, B and C. all right, where A is the semi major axis, B is the semi minor, C is the distance of any focus from center. All right. Is this step clear, everyone?
Yes, sir.
All right. Done writing?
1 minute, sir.
All right. And Ashma and Abdul, what about you? All right.
Done, sir.
Okay. Okay, Ashma. 1 minute more. All right. All right then. See, if this is the relation between A, B, and C, then we can take different cases here, special cases. Suppose C is 0. That means A square equals to B square. That means A equals to B. Right? Everyone? So when C, when C is 0, that means the origin or the center and the focus are merged together, right? There is no difference between them. And we are getting A equals to B. That means semi major equals to semi minor. If this and this are equal, that means this ellipse becomes a circle. All right. The focus is merged with the center. All right. When C becomes 0, ellipse becomes a circle. So we can say that circle is a special case of ellipse. Right?
So could you explain when circle becomes an ellipse?
All
Sorry,
right.
when ellipse becomes a circle.
See, this was the ellipse. We called this foci. I am
Yes.
saying C is 0. What was C? C was the distance between center and focus.
Yes, sir.
If this is 0, that means this focus and the center are merged together, right? This is not here.
Yes, sir.
And also I'm with this help of this relation, I'm getting A equals to B. A means this semi major axis, B
Yes,
means
sir.
semi minor, right? If they are equal, that means this distance and this distance is equal. So this becomes a circle.
Understood, sir.
All right, clear?
Yes,
Write
sir.
it down. When C is 0, ellipse becomes a circle, and we can say that circle is a special case of ellipse. All right, there is another case. If C is equals to A, all right, If C is equals to A, putting the relation, this is equals to A, that means A square equals to B square plus A square. This is cancelled, that means B equals to 0. If this is an ellipse and this is B, if B becomes 0, that means this part and this part merge together and form a line, right? Is this thing clear? Shavya, Ashma, Abdul?
So could you explain that again?
Again, all right. See, if I take a condition that C is equals to A, so using that standard equation, I can write A square equals to B square plus C square. I'm putting the value of C as A. That means A square equals to B square plus A square. A and A is cancelled, and we are getting the result B equals to 0. What
Yes,
was
sir.
B? B is the semi-minor axis,
Yes, sir.
this distance. If this is 0, that means this part and this part is merging with this line, right? Because this distance
Yes,
is
sir.
0. So ellipse becomes a line.
Okay, sir.
All right.
Yes, sir.
So ellipse becomes a line segment. Write it down.
Done, sir.
All right. Write down eccentricity. All right. Eccentricity. The definition is the eccentricity of an ellipse is the ratio of the distances from the center of the ellipse to one of the foci and to one of the vertices. All right. Can you read my handwriting? Do I have to read it out loud? Ashma, Shabbi, Abdul? I guess it's okay.
Yes, it's okay.
All right. So are you guys clear till now? Some people find it difficult.
Clear, sir.
All right. Okay, done.
Done, sir.
All right. See, they are saying the eccentricity of an ellipse is the ratio. That means this is a ratio of the distances from the center of the ellipse to one of the focus OF1 upon to one of the vertices OA. This ratio is E, all right, or eccentricity. And we know that OF1 is C, OA is A. That means we can write E equals to C upon A. This is the eccentricity of ellipse. All right. Or we can write C equals to AE. This is also very important because the coordinates of the focus was plus minus C comma 0, or we can write plus minus AE comma 0. Right, the focus was C comma 0 and minus C comma 0. And we know that C is equals to AE. That means we can write AE comma 0 or minus AE comma 0. Is it clear?
Yes, sir.
All right, write it down.
Done, sir.
All right. So write down standard equation of ellipse. All right. The standard equation looks like this: x square upon a square plus y square upon b square equals to 1. This is type 1. And type 2 is x square upon b square plus y square upon a square equals to 1. All right. The diagram is like this, and here the diagram is like this. Okay. This is a very bad drawing. All right. You draw it in a nice way. Write it down. All right. Done. Shabia, have you written this down? Standard equations of ellipse.
No, sir. I cannot see your screen.
Cannot see. Oh, wait a minute. All right. Is it clear now?
Yes, sir.
Okay. There are two standard equations of ellipse. One is like this. One is this. This is the diagram of this ellipse. This is the diagram of this ellipse. Not exactly like this, but you get the idea.
Done, sir.
All right. Write down latest rectum of ellipse. Okay, Shabia. What was latest rectum in parabola?
4A.
4A. Can you tell me the definition? No definition. Okay. Ashma, can you tell me the definition? All right, you can type it out. No worries.
Sir, is it the line that is perpendicular to the axis and it passes through the focus?
Absolutely right. So a line that passes through the focus and perpendicular to the axis and endpoints on the parabola, right? Three conditions we had.
Yes, sir.
It should be passing through the focus, perpendicular to the axis, and endpoints on the parabola. In the same way, this will be the latest rectum here, which passes through the focus, perpendicular to the major axis, and endpoints on the ellipse. Absolutely right, Ashma. All right. Is this clear?
Yes, sir.
Okay, write down the definition. Latest rectum of the ellipse is a line segment perpendicular to the major axis through any of the foci and whose endpoints lie on the ellipse. Exactly the same definition, only here the axis becomes the major axis. All right. So how to calculate these coordinates? We know the equation of ellipse, standard equation, x square upon a square plus y square upon b square equals to 1. The coordinates of this point, let me call this b. This point will be c comma something, let's call it L. Why C? Is it clear? Shavya, Ashma, Abdul? Why the x coordinate of the point B is C?
Yes, sir.
Right? Because the line is perpendicular and
Yes,
is
sir.
passing through C comma 0. All right. So I can put the x coordinate C and find the value of y coordinate. So this will be C square upon A square plus L square upon B square equals to 1. L square upon B square equals to 1 minus C square upon A square. This is equals to A square minus C square upon A square. So L square equals to B square into A square minus C square upon A square. And we know the equation that A square equals to B square plus C square. That means a square minus c square is equals to b square. I can replace this value here. This is b raised to the power 4 upon a square. That means L equals to b square upon a. All right. If this is b square upon a, that means this will be b square upon a also. That means total length is 2b square upon a. So length of lattice rectum in ellipse is 2b square upon a. In parabola, it is 4a.
If we consider vertical ellipse,
Yes,
then
if you take an ellipse of this kind, this is also 2b square upon a.
okay, sir.
All right. See, think it in this way. Just give me a minute. All right. If this is your ellipse and this is the vertical ellipse, nothing is changed. They are just rotated by 90 degree, right?
Yes, sir.
And lattice rectum is the width of this ellipse. So the width
Yes,
will
sir.
not be changing if you rotate it by 90 degree, right?
Yes, sir.
Okay, clear then?
Yes, sir.
Okay, write it down, the whole definition. So the whole derivation.
Done, sir.
Okay. Now last thing remaining of ellipse, write down type 1 ellipse. Where foci lie on x-axis. All right. If foci lie on x-axis, that means ellipse will look something like this, right? If the foci lie on x-axis, this is type 1 ellipse. Remember this. And the equation will be looking like standard equation x square upon a square plus y square upon b square equals to 1. All right.
Done, sir.
All right. Write down here foci, the coordinates of foci is plus minus c comma 0. And how to find c? Using the formula a square equals to b square plus
B square plus C square.
c square. Yeah. All right. The coordinates of center is 0 comma 0. vertex is plus minus a comma 0, length of major axis to a, length of minor axis to b. Length of LR is 2b square by a, and eccentricity is c upon a. Write it all down.
Done, sir.
Okay. Write down type 2. I'll explain, all right. Don't worry. Type 2, where foci lie on y-axis. That means this will be the foci, and ellipse will look something like this. All right. So this will be the major axis, and this will be the minor axis. The standard equation looks like x square upon b square plus y square upon a square equals to 1. All right. Compare these two. In the first equation, we had x square upon a square plus y square upon b square. And in this equation, we have x square upon b square plus y square upon a square. All right. So if I give you is this type 1 or type 2 ellipse?
Type 1.
Type 1. Why is it type 1?
So here A is greater than B.
Absolutely right. Because the denominator of x is more than y. So this is type 1. All right. Always look like this. Look for the bigger denominator. If x has the bigger denominator, then type 1. If y is the bigger denominator, then type 2. Is it clear? Ashma Abdul? All right. So the standard equation looks like this. Here the coordinates of foci Shabya, what will be the answer?
0 comma plus or minus C.
Absolutely right. And center will be
0 comma 0.
0, 0. Vertices
0, comma plus or minus a.
plus minus a. Remember this. Here we will not be writing plus minus b. All right. This is always 0, comma plus minus a. Don't
Yes,
get confused. Yeah. What is left? Length of major axis
2b.
2a. All right. Don't change the numbers here because we change the numbers in this equation itself.
Okay, sir.
All right. So here the coordinates will be 0, comma a and 0, comma minus a. And this is b, comma 0 and minus b, comma 0. All right. Never change the numbers here. Length of major axis is 2a. Length of minor axis
2b.
2b. All right. And length of latest rectum what is the answer here?
So
What is
here should we
already?
change the value?
No, it will not be changed. I told you the width will
Yes,
not be
sir.
changing, right?
Yes,
Yeah.
sir. 2b square by a.
2b squared by a. And eccentricity is c upon. Only the first three things will change. Foci, vertices. I guess two
So
things.
can we
right?
consider minus x square upon a square plus y
Wait a
square
minute.
upon b square?
You want to have this minus x square upon a square
Yes,
plus
sir.
square. No, this is not the equation of ellipse.
Okay, sir.
All right. Actually, when you read hyperbola, you'll get to know why.
Yes, sir.
Okay. Okay, so done writing.
No,
Ashma
sir.
Abdul? No. All right. Write it down, then we'll solve few questions.
Done, sir.
All right. So let's take this question, this ellipse. Find the length of major axis, minor axis, eccentricity, vertices, foci of the ellipse, x square upon 25 plus y square upon 16 equals to 1.
Sir, even lattice rectum.
Sorry.
So should we also find the length of lattice rectum?
Yes. Find all the quantities.
Okay, sir.
Length of. Do you want me to solve this or you can solve this?
So we'll try to solve.
All right. I'll give you a few minutes. Ashma Abdul, is it clear? All right, try to solve this question. All right, let's see how to solve this. Here, x square upon 25 plus y square upon 16 equals to 1. That means this is type 1 ellipse because the denominator of x is more. That means e square equals to 25. That means e equals to 5. And b square equals to 16. That means b equals to 4. First of all, I can find the value of c. E square equals to b square. You can just write plus 3. All right, don't worry about that, because if you look at the coordinates, we have already written plus c and minus c. That means c is a positive quantity.
Okay, sir.
Yeah. So 25 equals to 16 plus c square. That means c square equals to 9. That means c equals to 3. Now we have A, B, and C. So foci will be plus minus 3 upon 0 because this is type 1 ellipse. Vertices will be plus minus 5 upon 5 comma 0. Center is 0 comma 0. Length of major axis 2a, that means 10. Length of minor axis 2b, that means 8. Length of LR is 2b square upon a, that means 1632 by 32 by 5. And eccentricity E equals to c upon a, that means 3 upon 5. Clear? Ashma, Abdul, Shabya has already answered, I guess. Yes. Ashma and Abdul. No, you don't have to type the answer now. You can just check the answers, all right, in the whiteboard.
Pardon, sir.
Sorry.
So you were saying something.
No. It's all right. I was talking to Ashma and Abdul.
Oh, okay, sir.
Yeah. So let's try next question. Find all of these things. All right. The ellipse is 9x square plus 4y square equals to 36. All right.
Yes, sir.
And what will be the first step here? To divide 36, right?
Divide by 36.
Yeah. You have to make the right hand side 1. I'll give you a few minutes.
Done, sir.
Yeah, I need answers from everyone. Ashma, you need to send me the answers also on the chat, and Abdul also. I'm giving you a few more minutes. Yeah. Ashma, Abdul, I still don't have your answers. Are you able to solve this? Okay. I'll give you 2 more minutes. All right. Don't worry. But I need your answers. You need the notebook. Which exercise is it taken? Okay, I'm just writing down the question. All right. Don't worry. You can write down the question. This is the question, right? 9x square plus 4y square equals to 36. Okay, let's see how to solve this. First of all, let's divide 36 on both sides because we want 1 to be in the right hand side. So 9x square upon 36 plus 4y square upon 36 equals to 1. So this is x square upon 4 plus y square upon 9 equals to 1. Ashma, is this type 1 ellipse or type 2 ellipse? Ashma, is it type 1 or type 2 ellipse? Type 2, absolutely right. That means b square equals to 4 and a square equals to 9, right? Y square upon a square, x square upon b square. That means b equals to 2 and a equals to 3. The first thing is finding the value of c. So this is 9 equals to 4 plus c square. C square equals to 5. That means c equals to under root 5. Right. Vertices are, first of all, let's calculate foci. 0 comma plus minus c. That means 0 comma plus minus under root 5. All right. After that, vertices. Absolutely right. Length of major axis is 2a, that means 6. Length of minor axis is 4. 2b square upon a. B square is 4. 8 upon 3. No, you have to write 8 upon 3. All right. Don't go into decimal. Okay, so done. Yeah, let's try next question. Find the equation of the ellipse whose vertices are plus minus 13,0 and foci are plus minus 5,0. All right. I'll give you a few minutes for this also. Find the equation of the ellipse whose vertices are this and foci are this.
Sir, I have sent the answer.
Okay. Ashma, Abdul, I'll give you a few more minutes. All right. Yes, the major axis is along the x-axis. Absolutely right, because the coordinates are given as plus minus something comma 0, right? So we know that the vertices are given as plus minus a comma 0 when this is type 1 ellipse. That means the value of a is 30 and foci is c is 5. We can easily calculate the value of b. So b square equals to a square minus c square, that is 169, minus 25, that is b equals to 12, I guess. So the ellipse will be x square upon a square 169 plus y square upon 144 equals to 1. Absolutely right. Let's try another question. Find the equation of the ellipse whose length of major axis is 20 and foci are 0 comma plus minus 5. All right, I'll give you a few minutes for this also. All right, Shreya. We'll wait 2 minutes for Ashma. Yes, Ashma. The equation is type 2. Equation is x square. Absolute type. Abdul, what happened? See, the major axis is 20. That means 2a equals to 20. That means a equals to 10. All right, Abdul. Great. Look at here. See, major axis is 20. That means 2a is 20. A is 10. Foci are 0, plus minus 5. That means this is 0, plus minus c. So c is 5. You have the value of a, you have the value of c. That means b is 100 minus 25 under root, that is under root 75. So the equation will be x square upon b square, that is 75, plus y square upon e square, that is 100, equals to 1. Very easy.
Yes, sir.
So ellipse is finished. All right. Any doubts from this topic? Anything that you didn't understand clearly?
No, sir, it was clear.
It was clear. Okay. So your homework will be to finish the exercise till ellipse, all right, of NCERT. And also
Yes.
if you, yes, and